Hello friends, now we will see how to construct a DFA for accepting the set of strings that ends with 0, 0. Right, that ends with 0, 0 means the string should be of the form W is equal to X followed by 0, 0. X followed by 0, 0. This X may be replaced by symbols that belongs to 0, 1 whole star. 0, 1 whole star means that is epsilon or 0 or 1 or 0, 0, 0, 1, 1, 0, like that any sequence of symbols can be replaced in the position of X, but it should ends with 0, 0. Right? Now how we will construct a DFA? If you are using epsilon for this X, then what is the minimum symbol for W? W is equal to, first symbol is 0, 0. Next, if you are using 0 for this X, 000. If you are using 1 for X, 100. Again you are using 0, 0 instead of X, 4 zeros, like this. It accepts the sequence of symbols for this DFA. Consider first start state as Q0. Consider Q0 as the start state. Consider Q0 as the start state. First construct a forward path for the symbol 0, 0. After accepting the symbol 0, 0, it should halt in the final state. First from Q0, we are reading the symbol 0 and moving to the state Q1. Again from Q1, we are reading the symbol 0 and moves to the final state. The final state is named as QF here. For 0, 0, from start state to final state it is moving. Next we have to construct the remaining transitions for each and every state for all the symbols. Now for 0, 0 it is to the final state. If the string starts with 1, if the string starts with 1 means that is first symbol is 0 followed by 0, 0. First symbol is 1 followed by 2 zeros. It is an accepted string. First symbol is 1. For this one here we have to make self transition. If the first symbol is 1, we should not proceed in the forward direction. That is towards final state. So for this particular one, here we have to make self transition. Self transition for the state Q0 for the input symbol 1. Right? Next, instead of this, if you are having the symbol like this, 1, 1, 0. This is not accepted. This should not be accepted by this DFA because it should not ends with 0, 0. So for the second one, we should not make forward transition. For the second one, here we should not make forward transition. So for the second one, that is from state Q1, right? For the state Q1 or from the same state Q0, if you are again reading the symbol 1, it should reside in the same state Q0, right? If again the next symbol after this 0, that is 1, 1, 0, 0. Now it is accepted. For the first one, it is having self transition, and again for the second one also the same transition. 0, third 0 from Q0 to Q1, and for the fourth 0, it is moving to the final state, right? Again, after this 1, 0, instead of this third symbol 0, if you are having 1, instead of the third symbol 0, if you are having 1, whether it is accepted or not, it is not accepted. It should not be accepted by this DFA because it ends with 0, 1, not it should ends with 0, 0. It is not accepted by this DFA. Then how you will make transition for the second one? For the first one, self transition. For the second 0, moving from state Q0 to Q1. For the third one, we should not proceed to the final state. So for this third one, from the state Q1, we have to make back transition. We have to make back transition to the state Q1 for the input symbol 1. Right? After this, here 101 means for the first one self transition, second one is to the state Q1, third one again to the state Q0. After this 101, again you are having symbol 0, 0. Again you are having symbol 0, 0. Q0 to Q1, that is for this particular 0, and for the last 0 from Q1 to QF. Right? So now the string is called as an accepted string and also it reaches the final state. After reaching the final state, right? Now after reaching the final state, if you are having 1 in the last position, for up to this particular 0, it reaches the final state. After this, if you are having 1, now the string should not accepted by this particular DFA, not accepted string. So for this one, we have to make back transition. Right? Back transition is whether either to the state Q1 or back transition is to the state Q0. If you are moving to the state Q1, for this particular one, if you are moving to the state Q1 means for the Q1 from QF comma 1, if you are to the state Q1, after from Q1, if you are reading the symbol 0, if you are reading the symbol 0, again it moves to the final state. But this is not an accepted string. Now this is also ends with the symbol 10. It should not ends with symbol 00. So from QF, we have to make back transition to the state Q0 for the symbol 1. Right? And for 0, we are making self transition. Because ends with 00 means self transition gives same transition. It should reside in the same final state and it accepts any number of zeros. Right? So for the 1, we are making back transition. From Q1 comma 1, we are moving to the state Q0. Likewise, from QF also, for the input symbol 1, we are moving to the state Q0. Right? Next, how you will define the DFA? DFA A can be defined by using 5 tuples Q summation del Q0 and F. Here what is Q? Q is the set of states. What are the set of states here? Q0, Q1 and QF. And what is summation? Summation is equal to what are the input symbols? Alphabet 0, 1. Right? These are the alphabets. And what are the transitions here? We are having some 6 transitions. What are the 6 transitions? Transitions are first del of. Transitions are del of Q0, 0. Del of Q0, 1. Likewise, del of, next is for the second state. Q1, 0. Del of Q1, 1, del of QF, 0 and last transition is del of QF, 1. These are the transitions. Right? Inputs arguments for the transition functions are start state of the transition and ends, input symbol that leads to the end state of the transition. What is del of Q0, 0? See here Q0, 0 is to Q1. Next Q0, 1 is the same Q0. Next Q1, 0 to the state QF. Q1, 1 back transition, that is to the state Q0. QF, 0 self transition, the same QF. QF, 1 is back transition to the start state, that is equal to Q0. These are the set of transitions. And which one is the start state? Start state is Q0. Start state is Q0 and which one is the final state? QF is the final state. This is the DFA for the given condition. Next we will see the extended transitions of this particular symbol. W is equal to 110, 100. How to extend the transition and determine whether the given symbol is accepted or not. Yes, now we will see the extended transition to check whether the string is accepted or not. Right? How to write the extended transition means del of first start state, that is Q0, here what is our string? 110, 100. That is the given string. This can be written like this. By using extended transition, the extended transition can be represented like this. Del of Q0, 110, 100. This can be written as del of del dash of Q0, first input symbol 1, remaining symbol. That is, here we use this 1. Remaining symbol is 10100. These are the remaining set of symbols present in the given string. Now what is del dash of Q0, 1? What is the transition for Q0, 1? Again the same transition Q0. So it is del of, instead of this del dash of Q0, 1, it is replaced by Q0, 10100. Again, that is del dash of Q0, 1, remaining symbol, that is 0100. First symbol will be considered for making the transition. Here these are the remaining symbols present in the given string. Now what is del dash of Q0, 1? That is del dash of Q0, 1, the same cell transition Q0, 0100. Again del of del dash of q naught comma 0 comma 1 0 0. What is del dash of q naught comma 0? That is q1. So del of q1 comma 1 0 0. That is del dash of q1 comma 1 comma 0 0. What is q1 comma 1? That is back transition to the state q0. So del of q0 comma 0 0. Del of q0 comma 0 0 can be written as del dash of q0 comma 0 comma 0. That is del dash of q0 comma 0 is q1. So del of q1 comma 0, that is equal to qf. Qf is the final state. Qf is the final state. Hence the string w, that is 110 100 is accepted by the given DFA. If we reach the final state means then the string is accepted. Otherwise, if after reading the given input symbol, if we halt at the state either at q0 or q1, then the string is not accepted by the DFA. Now the string 110 100 is accepted by the given DFA. Right? Thank you.